Students, TCP/IP protocol suite के अंदर the layered architecture that we have deployed, it follows the same rules, the same set of principles that we just discussed in the protocol layering discussion. Students, first of all, there is logical connectivity between the layers on the source and the destination side. Students, the bidirectional nature of the function that is performed by each of the layers on the source and the destination is also one of the principles that we spoke about. Then we talked about the objects that are present on each side, each layer at the source and the destination. Ab students, in concepts ko employ karte hain in a TCP/IP protocol suite, and we'll go to a slide and we'll understand how these principles, how these concepts that we have understood when we were discussing protocol layering in general are applied to the TCP/IP protocol suite. Students, as you can see on the slide, once again we have got the same example network that we have discussed. In this example, you have got 3 LANs connected by 2 switches and 1 router in between. Students, first of all, you can see that there is a logical connection between the top layers, between the application and the transport layer at the source and the destination. So there is a logical connection from the application layer of the source to the application layer of the destination. There is a logical connection from the transport layer of the source to the transport layer of the destination. Similarly, you have got a logical connection of the network layer to the opposite end as well. Students, the bottom layers, the physical and the data link layers. As you can see, the logical connection does not span the whole of the path that the upper layers took. It is from the data link layer on one end to the switch or the router that's sitting in between. So what we can say is that the domain of the duty of the top 3 layers, application, transport, and network, is the internet. They span the internet and they go all the way to the other side, which is the destination side. But the domain of the duty of the 2 bottom layers, the physical and the data link layer, is the link, not the internet. The link that exists between that particular layer at the source and the logical connectivity of that with the switch and the router. Students, moving on to the next slide, we need to look at the function of these layers. We will look at the bidirectional nature of the functions performed by each layer. But before we do that, we need to once again see the objects that are exchanged, the objects that are created at the same layers on both ends. So we'll start with the application layer. And by the way, we have not shown switches in this slide because switches do not change objects. Only the hosts or the routers, the layer 3 routers, change objects. So at the application layer, our object is a message. Both on the source and destination side, our object is the message. At the transport layer, our object is going to be a segment or a user datagram. Students, network layer ke andar, we are going to have similar objects once again, and they are going to be datagrams. Then we'll have similar objects at the data link layer, and we call them a frame. And students, at the physical level, at the hardware level, the objects that we use, which are identical on both sides, are called bits. Important concept. So physical layers exchange data in the form of bits. The data link layer data that is interpreted by the opposite side data link layer is called a frame. The network layer data or the object is called a datagram, and it's also called a packet. On the transport layer, we have got a segment or user datagram, and then at the application end, we have got a message.